Welcome to this explainer. Today, we're going to totally shatter that illusion of the weightless digital cloud. You know, when we think of AI, we usually picture sleek code, weightless data, algorithms just kind of floating invisibly all around us.
Right, but today we are looking at the hard, physical reality of what it actually takes to make that code run. Because, as we'll see, the AI revolution is quietly driving a massive physical energy crisis.
Exactly. Because the reality is AI isn't some magic software living in the ether. It is entirely bound by physical steel, copper, and frankly, staggering amounts of electricity. AI lives in data centers. These are massive industrial facilities that are quietly drawing more power right now than ever before in human history. So treat this like our investigative dossier. We're going to breeze through the invisible infrastructure and the surging power demands, unpack this crazy paradox of baseload power, and then we'll get into big tech's massive pivot to nuclear energy and the climate dilemma it's creating. Let's just dive right in. Starting off with part 1, the invisible infrastructure, taking us from software to steel. The crucial point here is that as these models evolve to do really complex, real-time tasks, they demand an entirely new, massive scale of physical hardware. We're not just talking about generating a funny poem or summarizing a PDF anymore. Frontier AI is moving into real-time, multimodal reasoning. That means processing video, audio, and text simultaneously. It's even branching into physical robotics and autonomous agents. And this huge leap in capability, it means the hardware running these models has to be exponentially more powerful, which is acting as a severe physical bottleneck on our global power supply. Which brings us to our second point, the surging power demands, or what I like to call the actual weight of computation. Get a load of this number. Global data center electricity consumption is surging toward a mind-blowing 1,000 terawatt hours. To put that into perspective, data centers are already eating up over 6% of the total U.S. electricity supply. That is a massive slice of the national energy pie dedicated purely to keeping servers cool and computational processors humming. And you know, the burden isn't spread evenly at all. In major tech hubs, the geographic epicenters of our digital economy, these data centers are now swallowing over 40% of the available power grid capacity. Let that sink in. Almost half of the electricity flowing into these regions is going straight into server racks. It is literally straining local infrastructure to its absolute breaking point. And to understand why AI specifically is driving this massive spike, you just need to know this one multiple, 10x. An advanced AI query requires nearly 10 times the wattage of a standard conventional internet search. When you multiply that intense power draw by millions of active daily users generating continuous workloads, the energy scale becomes almost unfathomable compared to the traditional internet we were all using just 5 years ago. But here's where the whole efficiency argument completely breaks down. To make matters worse for grid strain, studies show that up to 13% of this massive data center capacity is just entirely wasted. It gets consumed by orphaned or improperly decommissioned zombie apps. These are essentially digital ghosts sitting on servers, drawing gigawatts of precious power 24/7 without providing any active utility whatsoever. It's wild. It really is. Okay, let's move to part 3, the baseload power paradox and the intermittency problem. Basically, what happens when the infinite demand for AI meets the very finite reality of our current green power grid? Here's the core grid bottleneck. While solar and wind power are expanding, they suffer from a fatal flaw for the tech industry, which is weather-dependent intermittency. I mean, the sun sets, right? The wind stops blowing. But hyperscale AI data centers, they cannot afford to turn off. They require 24/7 continuous baseload energy with 99.999% uptime. So clean solar and wind simply cannot currently provide the non-stop, hyper-reliable power required to keep these giant AI brains awake. And the scale of this paradox becomes even more alarming when we look to the near future. Just a single training run for a next-generation frontier model is projected to require multi-gigawatt power capacity. Just think about that. Turning on the computers to teach a single new AI system will soon require the exact same amount of electricity as an entire major metropolitan city operating at its absolute peak capacity. So how are they solving this? That brings us to part 4, big tech's massive nuclear pivot to bypass the grid. Tech companies are literally reviving historic nuclear sites to build a completely new energy landscape. Microsoft, for instance, has contracted with Constellation Energy to bring the 3 Mile Island nuclear unit in Pennsylvania back online. Yep, 3 Mile Island. Meanwhile, Google has committed to 500 megawatts of capacity from a pioneer in small modular reactors, or SMRs, called Kairos Power.
But they aren't just buying power, they are fundamentally changing how power is distributed. Regulatory bodies like the U.S. Federal Energy Regulatory Commission, FERC, are actually restructuring tariffs to allow for bring-your-own-power and co-located generation. What this means is data centers are finding ways to plug directly into nuclear reactors, bypassing our congested public transmission grids entirely.
Which leads us straight into our final section, Part 5, the climate dilemma and its unintended consequences. Right now, big tech is trapped between a rock and a hard place. On one hand, you have their very public, ambitious, net-zero corporate climate pledges, these big commitments to completely eliminate their carbon emissions. But on the other side, you have the immediate, staggering reality of AI development. If they pause to lower their energy consumption, they lose the AI race entirely. But if they accelerate to win that AI race, their energy demands skyrocket, threatening to completely obliterate those environmental pledges.
Exactly. I want to leave everyone with this really provocative thought from our sources. The future of AGI isn't just about who writes the best code. It belongs to whoever can generate the physical zero-carbon energy to power it.
Spot on. The invisible infrastructure crisis is ultimately a geopolitical competition. The nation that manages to supply this massive, continuous electricity demand without destroying the climate, they're going to hold the keys to autonomous industries and artificial general intelligence.
Turns out the future of the digital world is absolutely going to be decided by the physical power grid.